excellent performance of the South Korean KSTAR tokamak. South Korean physicists in the KSTAR tokamak managed to keep the plasma at a temperature of 100 million degrees Celsius for 48 seconds. This achievement was made possible by the modernization of the device that KSTAR has undergone in recent years. The Korea Fusion Energy Institute (KFE) announced that during the last KSTAR, Korea Superconducting Tokamak Advanced Research Tokamak Science Campaign, which lasted from December 2023 to February 2024, it managed to maintain the plasma at a temperature of 100 million degrees Celsius for 48 seconds. Moreover, the KSTAR team also managed to keep the plasma in the so-called H mode for 102 seconds. In this mode, the plasma retains energy much longer, but is unstable. A fully operational fusion power plant must operate in just such a regime, enabling the maintenance of high temperature and high density plasma. To effectively research and develop fusion energy, it is necessary to develop reliable technology that can maintain high temperature, high density plasma for extended periods of time. To put it very simply, a thermonuclear reaction involves the fusion of two nuclei of lighter atoms, deuterium, tritium, into one heavier one. This combination releases a huge amount of energy. However, to carry out thermonuclear fusion, the main energy source of stars, hydrogen, must be heated to a temperature of about 100 million degrees Celsius. Only then will the lighter atoms be able to combine to form heavier ones. In the Sun, this reaction occurs at much lower temperatures. This is made possible by the enormous pressure inside the star. A powerful and stable magnetic field is needed to keep the plasma in check. 1 kilogram of deuterium, which occurs naturally in seawater, and there is plenty of it, could power hundreds of thousands of homes. We would ensure energy security for decades. However, controlling these reactions is still the future. Scientists have been researching fusion for decades, using tokamaks such as KSTAR, among others. Tokamak is a design developed by Russians in the 1950s. The first device of this type was created in Moscow. The main compartment is torus-shaped. Inside it, researchers can create extremely hot plasma, which is kept in check thanks to powerful electromagnets that generate a magnetic field. In 2018, South Korean physicists obtained plasma at KSTAR for the first time at a temperature of 100 million degrees Celsius. In 2020, they managed to keep it at this temperature for 20 seconds. In the following years, they kept the plasma this hot longer and longer. During the last science campaign, they held it for 48 seconds. This achievement was made possible thanks to the modernization of the tokamak. In recent years, South Korea's artificial sun has improved the efficiency of its plasma heating systems and control techniques, resulting in a new record. Among others, diverters were replaced. These are parts of the device that have direct contact with the plasma and whose task is to remove contaminants from the plasma. Artificial intelligence components were also installed to improve the performance of the tokamak. Even though this was the first experiment conducted in the environment of new tungsten diverters, thorough testing of the equipment and preparation of the campaign allowed us to achieve results exceeding those obtained in previous experiments, said Dr. Siwoo Yoon, director of the KSTAR Research Center. The ultimate goal of physicists working on KSTAR is to maintain the plasma at temperatures above 100 million degrees for 300 seconds. They intend to achieve this by 2026. The results obtained in the KSTAR tokamak are admirable, but they are not the best results achieved in this field. The record for maintaining plasma is held by scientists from China. In 2021, they achieved a plasma temperature of 120 million degrees Celsius and maintained it for 101 seconds. A year later, they kept the plasma at a temperature of 100 million degrees Celsius for 1056 seconds. Last year, they boasted of maintaining plasma in H mode for 403 seconds. Water vapor discovered in Europa's thin atmosphere. Observations using the Hubble Space Telescope have revealed the persistent presence of water vapor on Jupiter's ice-covered moon Europa. Interestingly, the analysis showed that water vapor in the thin atmosphere occurs only on one side of the moon. Europa, one of Jupiter's 79 moons, is the fourth largest moon of Jupiter and the sixth largest moon in the Solar System. It is an icy ball larger than the dwarf planet Pluto but slightly smaller than Earth's moon. The surface of Europe is frosty, with an average temperature of -170 degrees Celsius. However, astronomers suspect that Europa hides a huge ocean under its icy crust, which may hold up to twice as much water as Earth's oceans. Thanks to the temperature coming from the interior of the Moon, the oceans may have conditions favorable to complex chemical reactions. Some researchers consider the possibility of microbial life there. Now a team of scientists has discovered evidence of persistent water vapor in Europa's thin atmosphere. Previous reports of water vapor on Europa involved geyser activity. Observations using the Hubble Space Telescope in 2013 and data from the Galileo spacecraft newly analyzed in 2018 confirmed that geysers eject plumes of water vapor into space. A description of new observations regarding the constant presence of water vapor in Europa's thin atmosphere was published in Geophysical Research Letters. This discovery is the result of a new analysis of archival images taken by the Hubble Space Telescope between 1999 and 2015. Researchers using a technique developed by Lorenz Roth of the Royal Institute of Technology in Stockholm, which recently resulted in the discovery of water vapor in the atmosphere of Ganymede, another moon of Jupiter, found evidence of the permanent presence of water vapor on Europa. The time range of the analyzed images suggests the long-term presence of water vapor. Previously, it was believed that Europa's thin atmosphere consisted only of oxygen. but detailed analyses of archival data recorded using the STI's Space Telescope Imaging Spectrograph on the Hubble Space Telescope showed that water vapor hovers just above Europa's surface. However, it is not evenly distributed over the entire surface of the object, but occurs only on one half of the Moon, the one that faces away from the direction of the Moon's motion along its orbit. The reason for this asymmetry is not entirely clear. Observing water vapor on Ganymede and on the back side of Europa allows us to better understand the atmosphere of the icy moons, Ross said. However, the detection of stable water on Europa is a bit more surprising than on Ganymede because the surface temperatures on Europa are lower than on Ganymede, he added. Scientists explain the presence of water vapor on the surface of Europa and on Ganymede as sublimation of water ice, i.e. the transition of ice directly from the solid state to water vapor. Bypassing the liquid phase. Scientists will soon have the opportunity to learn more about Europa and other icy moons in the solar system. The Europa Clipper mission is scheduled to launch this year and will be used to conduct in-depth research on the icy moon. The spacecraft will carry 9 science instruments, including cameras and spectrometers to image the lunar surface in high resolution, a magnetometer to measure the strength and direction of the magnetic field, and an ice-penetrating radar to determine the thickness of the ice crust over the ocean. During its mission, the spacecraft will make 40 to 45 passes over Europa, examining the Moon's icy crust and subsurface ocean, providing data necessary to assess Europa's environment. But this is not the only mission heading to Europe. The European Space Agency's Jupiter Icy Moons Explorer, JUICE, launched in 2022 and undertakes to explore the atmosphere and magnetosphere of Jupiter and 3 of its moons, Europa, Callisto and Ganymede. The satellite will cover a distance of 600 million kilometers and will be in Jupiter's orbit in 2029. JUICE will conduct observations for at least 3 years. Archaeologists discovered flutes dating back 12,000 years. Years made of bird bones. Israeli archaeologists discovered a collection of flutes dating back 12,000 years. These instruments were made from bird bones and are some of the oldest musical instruments in the world. Scientists believe they may have been used for ritual purposes, to create music or for hunting. Archaeologists discovered 7 flutes at the Ain Mala site in northern Israel. These are the oldest wind instruments ever found in the Middle East. They number 12,000 years, which means that they come from the period when people switched from a hunter-gatherer lifestyle and began to develop agricultural settlements. The instruments were made from the bones of small water birds, teals and coots. According to the currently used criteria, these instruments should be classified as aerophones, i.e., instruments in which sound is created by air vibrations. These flutes, as researchers found, imitate the sounds of some birds of prey and, apart from simple entertainment and creating music, could have been used for ritual purposes or for hunting. The description and results of the research were published in the journal, Scientific Reports. Scientists believe that these instruments were created by the Natufians, representatives of a culture that existed between 13,000 years BC to 9700 BC. They were also one of the last hunter-gatherer peoples to inhabit the Levant in the Middle East. Researchers estimate that the flutes were made approximately 12,000 years ago. In a place where previously 1,112 bones from 59 species of birds were also found. What is extraordinary about these aerophones is where they were found. These are the first such flutes found in this part of the world and made so long ago. Researchers found that with the help of these flutes, people playing them were able to imitate the sounds made by birds, including those that were hunted in that area at that time. Examining them in this respect was possible thanks to one well-preserved specimen, which had both an intact mouthpiece and holes for plugging with fingers. The sounds it makes can be heard in the recording below. All 7 flutes were made by carving and scraping bone using stone blades. They were created from the long bones of 2 species of birds, teal and coot. They also show signs of wear, which means that their creators actually used them often. According to scientists, they imitate the sounds of kestrels and sparrowhawks. There are many indications that the purpose of producing these flutes was their later use during hunting. However, scientists also take into account that the purpose of these flutes, apart from the sound they produce, may have had nothing to do with birds at all. Perhaps their creators simply used them to compose music, or they needed them for practices related to their spiritual sphere. The Rwandan genocide modified the DNA of the victims and their offspring. Unimaginable suffering left its mark on the DNA of the survivors of the 1994 Rwandan genocide. Traces of this psychological trauma have been passed on to the next generation and can be found in their genetic material. Scientists from the University of South Florida and the University of Rwanda examined the genomes of Tutsi women who were pregnant and living in Rwanda at the time of the 1994 genocide. Researchers also analyzed their offspring and compared their DNA with other Tutsi women and their offspring who lived in other parts of the world at the time of the genocide. The first study of this kind was published in the journal, Epigenomics. It is estimated that approximately 1 million people of Tutsi origin were murdered in just 100 days from April to July 1994. During the Rwandan Civil War, sexual violence also became widespread at that time. According to estimates, approximately 150,000 to 250,000 people were raped during the crisis. Women. The Rwandans who are taking part in this study and the entire community really want to know what happened to them. There are many cases of PTSD and other mental health disorders in Rwanda, and people want answers as to why they have these problems. Derek Wildman from the University of South Florida. DNA is sometimes perceived as a code that we have permanently, but the expression of some genes can be changed through epigenetic changes, which are influenced by lifestyle. life experiences or the environment we live in. In pregnant women who experienced terror during the Rwandan genocide, scientists have discovered chemical modifications to DNA that have previously been linked to a greater risk of developing mental illnesses such as post-traumatic stress disorder, PTSD, and depression. The same DNA modifications were also found in their offspring, who were fetuses at the time, indicating that the epigenetic changes were passed on to them. Epigenetics refers to stable but reversible chemical modifications made to DNA that help control gene function, said Monica Udden of the University of South Florida. This may occur in a shorter time than it takes to change the basic DNA sequence. Our study showed that prenatal exposure to genocide was associated with an epigenetic pattern suggesting reduced gene function in offspring, she added. The research team will look at DNA from blood samples taken from 59 people. About half of them were personally exposed to the horrors of war or were in their mother's womb at the time. The researchers defined exposure as being affected by the trauma of genocide, rape or evasion of capture, witnessing a murder or serious weapons attack, and observing dead and mutilated bodies. While this study focuses specifically on the effects of the 1994 Rwandan genocide, it supports previous research that shows that what happens during pregnancy can later have long-term effects. Many symptoms do not appear until later in life. Such evidence supports the need for increased efforts to protect the safety and emotional and mental well-being of pregnant women. People who were in the womb during the genocide are beginning to enter the period when they will have children themselves. Scientists hope to investigate whether this trauma will have an epigenetic effect on the third generation. Now they're waiting for a new, larger batch of DNA samples to learn how similar trauma might affect the risk of certain mental health disorders, such as PTSD. This study is part of an effort to empower African scientists in the field of genomics, increasing their independence and ability to build the infrastructure needed to improve genetic research across the continent and ultimately better develop human genome data around the world.